Okay, so this is section 2.4, and we're going to talk about atomic mass unit. Atomic mass unit is a unit for measuring the mass of an atom. Okay, the definition is it's equal to exactly 1/12 of the mass of carbon-12 atoms. Carbon-12 has become the standard for which all other masses are calculated. Okay, atomic mass, which is also called atomic weight, is the average atomic mass for the naturally occurring element expressed in atomic mass units. So atomic weight is a weighted average of all the isotopes. So basically the mass of the isotopes are done with a spectrometer that measures the accurate mass of atoms. It produces a mass spectrum shown with the relative number of atoms for each mass. So here is neon. Neon has 3 isotopes, 10 protons, 10 neutrons, 10 protons, 11 neutrons, and 10 protons, and 12 neutrons. So this is neon 20, neon 21, and neon 22. And so when you do the mass spec of these, you get a mass right at 20. Okay, and this is the abundance of, or basically the portion of the atoms that are that mass. Okay, so fractional abundance, which is represented by this 0.9051, is the fraction of the total number of atoms that are composed of a particular isotope. And then I see neon 21 is down here with 0.0027 as a fractional abundance, and neon 22 is 0.0922. Now, sometimes you will see this referred to as a percentage. So if I just multiply this by each one of these by 100, the abundance, not the fractional abundance, but the abundance would be 90.51 for this one, 0.27% for that one, and 9.22% for that one. Our textbook tends to do just fractional abundances, which is a fraction. So if the number is greater than 1 for any of them, then it is going to be a percentage. And if it's less than 1 for all of them, and it adds up to be 1, that's the other way, is it can add up to be 1, then if you do that, then it's fractional abundance. So if it adds up to be 100, it's just percentage, it's just an abundance. You have to divide each one of these by 100. If it adds up to 1, you can use it as is. So number 52 in the book says an element has 2 naturally occurring isotopes with the following masses. So here I have the isotope mass in AMUs and the fractional abundance. To do this problem, I'm going to multiply the 49.9472 times the 2.5 times 10 to the minus third. So when I multiply this times that, I get 0.1249. I'm going to do the same thing for the 50.944. I'm going to take this times that, and when I do that, I get 50.82. So once I have multiplied each of the masses by its fractional abundance and gotten that number for however many isotopes there are, I then want to sum these. Okay, and so when I do that, I get 50.94. If I look at the periodic table for the element that has an atomic mass, which is what's listed on the periodic table, it is the element that has a mass of 50.94 is vanadium. Okay, so this is a lot like doing your GPA. Okay, your GPA, which hopefully somebody has explained to you, is a weighted average also. So each letter, A is a 4 points, B is a 3 point, C is a 2 point, D is a 1 point, and F is a 0 point, is taken by the number of credit hours that that class has gotten. Okay, so if you were to get an A in chemistry, which is 4 credits, a B in English, which is 3 credits, and a B in, say, history, which is 3 credits, okay, you would take the 4 times the 4 to get 16. You would take the 3 times 3 to get 9, so that would be 25. Another 3 times 3 to give me another 9, so that would give me 34. And then I divide by the total credit unions, which is 10. So my GPA would be then 3.44. Okay, so it's basically the same type process as you do to calculate your GPA. 2.54 says an element has 3 naturally occurring isotopes with the following masses. So I have my mass here of 27.977 with a fractional abundance of 0.9221, 28.976 with 0.0470, and 29.974 times, which in the fractional abundance 0.0309. Again, if these were multiplied by 100, it'd be an abundance of 92.21, 4.70, and 3.09. I do the same process. 27 times the 0.9221 gives me 25.80. 28.976 times the 0.0470 gives me 1.362. And 29.974 times the 0.0309 gives me 0.9262. And then once I have all of these three numbers, I add these three numbers together, so 25.80 plus 1.362 plus 0.9262, and I get 28.09. I'm going to round it to 4 significant figures. The units are AMUs, okay? And so when I look on the periodic table for what has a mass 28.09, the element is silicon. And that's the end of this section.